Assalamualaikum and hello everyone. My name is Nur Ala Shafika binti Hanizam and I am from Group 2. So we are going to present experiment 1, which is a gravimetric method for determination of chloride in soluble salts. So for the introduction, one of the most widely used technique in lab is the precipitation of silver chloride using silver nitrate, which is then used to gravimetrically measure the amount of chloride in the sample. Any halogen containing an organic compound can be dissolved in water and treated with silver nitrate to produce silver halide precipitate. Gravimetric analysis is a method in analytical chemistry to determine the quantity of analyte based on the mass of a solid. So chloride salt was used for the test material in this lab. White precipitates of silver chloride were produced by treating the salts, both known and unknown, with a silver nitrate. At first, the silver chloride was colloidal solution. Following further heating, particle growth took over the nucleation process and the precipitate separated as a coagulated mass. So, objective for this experiment is number 1 is to apply a gravimetric analysis to quantitatively determine the amount of chloride in sample. And number 2 is to recognize and apply the concept of stoichiometry.
Okay, now for methodology part B, 0.5 gram of NaCl was added to the beaker and distilled water was added to dissolve NaCl. 8.4935 gram of AgNO3 was weighed and distilled water was added. The solution of AgNO3 was transferred to the 250 ml volumetric flask for dilution. 125 ml of AgNO3 used for each beaker. Silver nitrate was added slowly with continuous stirring until the coagulation of silver chloride was observed. 6 ml of 6 mol of nitric acid was added each beaker. The mixture in the beaker were heated to digest the solution for 10 minutes. Small volume of silver nitrate was added while heating the beakers until the solution stopped becoming cloudy. The precipitate in each beaker was filtered and was 8 times with deionized water mixed with 0.5 of 6 mol nitric acid. The funnel was wrapped with aluminium foil, placed in the oven at 120 degrees for 90 minutes. The funnel was took out and placed in desiccator to cool to room temperature. Lastly, the mass of filtered funnel and their respective content was weighed. For part C, 5 gram of flour was weighed using an analytical balance. 50 ml of distilled water was added to the beaker and the mixture was stirred to dissolve sodium chloride present in flour. It was set for 30 minutes to ensure full dissolution of the salt. The solid residue of flour was removed and filtered using filter paper. The solution was heated gently on a hot plate to about 60 to 70 degrees. Then silver nitrate was slowly added dropwise while stirring. A white precipitate of silver chloride formed immediately.
In question 1, we analyze the result and the calculations. When we added the silver nitrate to the sodium chloride solutions, it formed a white silver chloride precipitate. After filtering, drying, and weighed the precipitate, we found chloride percentage of 72.28% and 65.08%, which were higher than the theoretical value of sodium chloride, which is 60.66%. The table in our report highlights the difference, showing the effect of possible error like excess silver nitrate, which may have led to extra silver compound in the precipitate. These highlight the precision required in gravimetric analysis, especially for complex samples like flour.
So I will explain about the discussion question 2. Relate the technique of gravimetric to concept of stoichiometry. Gravimetric analysis and stoichiometry are two essential concepts in analytical chemistry that play significant roles in determining the quantities of substance in a sample. In this experiment, when silver or argentum plus react with chlorine, it will produce argentum chloride, and it shows the ratio is 1/1, knowing that each mole of argentum chloride corresponds to 1 mole of chloride. Allow the use of stoichiometry calculation to determine chloride in the sample.
For question 3, we discuss how this method is applied in industry. In food industry, it used to measure salt in products like flour, ensuring quality and regulatory compliance. In water treatment, gravimetric analysis check chloride levels to maintain water quality, and in the soap industry, it controls sodium chloride, which affect the product's texture. This application emphasizes the role of gravimetric analysis in ensuring consistent quality across various sectors.
Question 4, determine the coefficient of variation of the data. So first, the formula of coefficient is standard deviation over mean. So we need to find the value of mean and the value of standard deviation. So for the mean, we take the value from the percentage of chloride in natrium chloride from filter funnel A and B. So the value is 72.78 and 65.08. So for the value of the mean is 68.68%. So for the standard deviation, the value is 5.0911, and we substitute the value into the coefficient formula, which is 7.4120%. So for the next question, in the lab manual, already give the formula, which is gravimetric factor equal formula weight for chlorine over formula weight for argentum chloride. So first, we substitute the formula weight chlorine, and we substitute the value for formula weight argentum Cl, which is 35.45 over 143.31, and we got 0.2473.
After forming the argentum chloride precipitate, first thing first is that we must determine the weight of it. To find the mass of chloride within the precipitate, we need to take the value of gravimetric factor, which is the ratio of molar mass of chloride to the molar mass of argentum chloride, and multiply it by mass of argentum chloride. This gives us the mass of chloride. With the mass of chloride in hand, we then can calculate the chloride percentage in the sodium chloride sample by using the formula of mass of Cl over mass of sodium chloride samples times multiply it by 100. After that, we find that the percentage of chloride in the treated funnel A is 72.28%, and for treated funnel B it's 65.08%.
So in conclusion, the objective was not fully achieved in the experiment. Based on the experiment, the gravimetric method was successfully achieved. The percentage for chloride in treated funnel A is 72.78%, and the percentage for chloride in treated funnel B is 65.08%. In this experiment, the second objective was not achieved due to no precipitate form. This is because the content of chloride is absent in the flow. Therefore, the stoichiometric concept cannot be applied.
That's all from us. Thank you.